Welcome, dear ladies and gentlemen, to my presentation about the impact of the oxytocin receptor antagonist cligosiban on human prostatic tissue by using live imaging. But first, some introductory words. We're working due to the fact to find new therapeutic options to treat the benign prostatic hyperplasia, which is also called BPH. This is a non-malignant disease which already affects about 60% of men at the age of 40 to 50, and the prevalence is steadily increasing. There are several pharmacological treatment options for BPH, but they often result in serious side effects or fail to prove efficacy. Oxytocin, a hypothalamic hormone, was suggested to affect the contractility of the smooth muscle cells in the male reproductive tract and therefore increasing the smooth muscle cell tone. That's why oxytocin has been in focus of researchers for more than 60 years, but there is still no medication which would interfere with the oxytocin signaling pathways. That's why we wanted to investigate the contractile effect of oxytocin on prostate tissue and, of course, test the effect of the antagonist cligosiban on the prostate tissue for the first time, by the way, as an inhibitor of the oxytocin receptor. After collating patients' approvals from the University's Hospital of Giessen in Marburg, we get non-malignant samples from patients who are undergoing the transurethral resection of the prostate, the so-called TURP. This is how the samples afterwards look like. We prepared them, embedded them in collagen, and then started our investigation with the live imaging method. That means that we filmed 2 videos. We always started with the no treatment period, and in the first video, after the no treatment period, the oxytocin edition followed, and the second edition was cligosiban. In the second video, we did it in reverse order. At the end, we performed a vitality check to make sure that our samples were vital during the whole experiment. Here I want to show you one representative video of our Oxytocin First movie. Oxytocin First just means that the first edition after the no treatment period was oxytocin. Please notice how the movements are changing after each edition. So here you see the no treatment period with contractions, especially in the middle of the prostatic tissue. After the addition of oxytocin, I think it's pretty visible for everyone that especially the contractions frequency has increased. And after the addition of cligosiban, we still see some smaller movements, but not in this high amplitude like we saw it before. Now about the statistical analysis. Let's start with our Oxytocin First movies. Like you can see in the population distribution graph and also on the p-values, we get significant results. We compared each section of the movie to another. That means the no treatment period was compared to the oxytocin period, oxytocin to cligosiban, and cligosiban again to the no treatment period, and our p-value values were the movement changes between 2 sections. And like you can see, oxytocin, we have significant results. So oxytocin was able to induce contractions in the prostatic tissue, and when adding cligosiban as the second edition, we also see a significant results, which again shows us that cligosiban was able to inhibit the oxytocin-induced contractions. And we have significant results compared cligosiban to the no treatment period that showed us that cligosiban was able to inhibit oxytocin-induced contractions, but not in that high power to come back to the baseline movement from the no treatment period. It looks a bit different in the statistical analysis of the cligosiban first movies. Like you can see in the population distribution graph, each of the three graphs is kind of overlapping another graph. And the p-values also show non-significant results. But this is great as well, because we wanted to show that when cligosiban given first, it does not disturb spontaneous contractions in the prostate, because these spontaneous contractions are very important for a functioning prostate, and on the second hand that it would be able to block the oxytocin receptors, so that's why oxytocin cannot work and induce contractions anymore. That's why we're also very happy about these results. This is just a summary of all the results I already told you in the 2 slides before, and if you want you can read about it in my abstract. That's why I don't want to go that much into detail on this slide. Just a short summary. The tissue shows spontaneous contractions. Oxytocin is able to induce contractions in the prostatic tissue. Cligosiban can inhibit these contractions, and it does not disturb spontaneous contractions but inhibits the oxytocin effects afterwards. To conclude, I want to say that since the oxytocin pathway has been discussed to be involved in the physiology of male reproduction, cligosiban could be a promising therapeutic option to treat BPH in the future. Thank you very much for your attention. Give feedback and ask questions using the comment section.